two projects. In this video, we are going to explain about the project that is XAI Enhanced Machine Learning for Obesity Risk Classification, a stacking approach with Lime explanations. So before getting into the execution, first let us understand what is this project about. Obesity. It is really big health problem across the world right now. It doesn't just mean gaining weight. It actually increases the chances of getting serious diseases like heart problems, diabetes, strokes, and even some types of cancer. One of the main reasons more and more people are facing obesity is because of the way we live today. Many of us sit for long hours, don't sleep properly, and often eat processed or unhealthy. Doctors usually use something called body mass index. We call it as BMI in short, which is just a calculation of your weight compared to your height to check if someone is overweight or obese. But the problem with body mass index is that it is not always accurate. For example, a muscular person might have a high body mass index and still be very healthy, while the other person with same body mass index could actually have too much body fat. It also doesn't consider the age, gender, or lifestyle habits, which all play an important role in understanding someone's actual health. So, even though researchers have tried using machine learning models to predict obesity, there are still some big issues. One problem is that many of these models are not very reliable. You can't always trust the results. Another issue is that they work like a black box. That means they give you an answer, like whether someone is at risk, but they don't explain you why they came to that decision. In healthcare, that is a big problem because doctors and patients need to understand the reason before they can act on it. And on top of that, some methods only focus on one thing like body mass index, but the obesity isn't that simple. It is influenced by many factors like age, gender, lifestyle, and eating habits. Just looking at one measure misses the bigger picture. That's why there is need for better systems that are not only accurate but also clear and transparent so people can trust them and actually use them for early prevention and better health decision. So in this project, we built a system to predict a person's obesity level accurately. The system is not just about giving results, it is also designed to be understandable. So people can see what factors are influencing the predictions. So we use dataset from UCI repository which contains the information about individuals' diet, physical activity, other personal characteristics. So instead of relying on just one model, we have combined multiple machine learning models to make the predictions stronger and more reliable. So here we are using light GBM, logistic regression, and random forest as the main models. Each of these models has its own strengths. So combining them allows the system to make better decisions, that is better predictions, than any other single model. And to bring all these predictions together, we use another model called stochastic gradient descent, that is SGD, as a meta classifier. The final step refines the results from the base models and improves overall accuracy and generalization. In simple terms, this ensemble approach helps the system take the best parts of each model to make smarter and more trustworthy. So here we are using ensemble stacking approach in which we will be combining all these models. And here, so before we use the data to train our models, we need to clean and prepare it properly. For example, some features in the data set are categorical like gender or eating habits. So we convert them into number format that the model can understand. And the numerical features are also scaled using min-max scaling, which just puts all the values into the same range. So no single feature domains that is dominates the learning process. And sometimes the data set has uneven classes, that is uneven class distribution, meaning some obesity levels have the way more examples than the others. To fix this, in this project we are using synthetic minority oversampling technique. It's a technique that generates synthetic samples for the underrepresented classes, making the data set balanced. And we also want the model to focus only on the most important features. For that, we have used recursive feature elimination with cross validation technique, which we call it as RFECV in short, which helps to pick the most important features that actually matters. Finally, to make sure the predictions are understandable, here we are using explainable AI models that are LIME and SHAP, a popular explainable tool, which are popular explainable tools here. LIME is local interpretable model agnostic explanations. So Lime looks at age prediction and tells us which features had the biggest influence. So instead of just giving a black box result, the system can explain why it thinks someone falls into a certain obesity category, making it much more transparent and trustworthy. And to further improve the performance of this project, here we have used some extensions. So we have added some enhancements. So first, as an extra step, to make the system even better, we have used something called SVMS mode. So that is SVM mode. Basically, sometimes the data set has very few samples of certain obesity categories, which makes it hard for the model to learn properly. So this SVMS mode solves this by creating new synthetic samples for smaller cases so the model can understand them better and make more accurate decisions. And we have also integrated the other ensemble model voting classifier. So it is same like stacking classifier, but it works more advanced. So instead of relying on just one model, this combines the predictions from several different models and takes kind of majority vote to decide the final outcome. This makes the system more reliable because of it is not depending on a single model that makes mistakes, and it uses the strengths of multiple models together. And here we have added another explainable AI technique, which is XAI SHAP, to understand why the model has made that prediction. And we have developed a web application using Flask so people can interact with the system directly. The app has user login for security, and users can enter their personal details and lifestyle habits. Once they do that, the system uses the trained models to predict their obesity risk and shows the results in simple, easy to understand way. This makes the whole system practical and user friendly. Moving on to implementation, to implement this project, we have followed the steps which are mentioned in the flow of work. So let's understand what have we done. So first we have imported all the necessary Python libraries that will help us handling data, building models and visualize results. These include libraries for machine learning, data processing and plotting the graphs. Then comes data exploration. So at this stage, we collect the data set from UCI machine learning repository and take a close look at it. This helps in understanding what features are available, how the target classes are defined, and what the overall structure of the data looks like. Then we have data visualization. So here we visualize the data to get a better understanding of it. First, we look at the distribution of the target classes to see if someone classes have more examples than the others. Then we create a correlation matrix to see how different features are related to each other. Then comes data pre-processing. So at this stage, before feeding the data into models, we need to clean it and prepare it. So we do data mapping, which converts categorical features like gender or diet habits into numerical values. Then comes normalization. So here we scale the numerical features using min-max scaling. So all values are onto the similar range. Then we do data splitting, where we separate the data set into training and testing proportions. Then comes balancing. So here we use Smotin, that is Smotin C, to generate synthetic samples for underrepresented classes, making the dataset more balanced. Then comes feature selection. So at this stage, we use recursive feature elimination with cross validation, that is RFECV with logistic regression, to pick out the most important features. This ensures the model focuses on the features that actually matters for predicting the obesity. Then comes train and test split. So here the data set is split into training and testing. So here we use 80% of the data for training, 20% for testing. So the model can learn from the most of the data and then be evaluated on unseen data. Then comes model training. So here at this stage, we train multiple machine learning models to see which performs the best. And all the models are evaluated using accuracy, precision, recall, and FN score. Then comes performance visualization. So all the performance of these metrics will be visually represented through graphs. And the best performing model will be saved for the future use. Then comes explainability part. So here we are using explainable AI techniques that are Lime and SHAP. Lime is a proposed model and SHAP is the extension. So these are used to interpret the predictions and identify which features had the most impact on the obesity classification. Coming to front end, here we have developed a web-based interface that is by using Flask, where users can give input features that will be pre-processed and saved. I mean, train model will be it will be fed to the train model, and train model will be giving us a prediction, predicting whether the person is obese or not. Moving on to the algorithms used, these are the algorithms used in this project. So here we have the algorithms used. So here we have used ADA Boost perceptron, Gaussian naive Bayes, stochastic gradient classifier, support vector machine, KNN classifier, neural network classifier, decision tree classifier, extra tree classifier, bargain classifier, random forest classifier, gradient boosting classifier, logistic regression CV, XGBoost classifier, LGBM classifier, and the proposed model stacking classifier, extension model voting classifier. And to implement this project, basically we need two kinds of requirements, which are hardware and software. So in hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, open the code folder that contains source code files. So these are the source code files of this project. Let's understand what are these. Here we have model folder in which we have algorithm information which are stored in .h5 files, numpy files, pickle files, and they will be loaded into the project code during runtime of the application. And here we have obesity level data set. So this is the data set that we have used in this project to predict whether the person is obese or not. It's opening. So here we have multiple attributes. Here we have age, gender, height, weight, family history, favorite, FAVC, FCVC, NCPCAC, all other parameters which impact in predicting whether the person is obese or not. Here we have different levels. So we will be training the data, that is, we will be training all the models on this data to predict whether the person is obese or not. Let's close this, get back. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the test cases. So in this, we have test cases that we will be using in the front end. And here we have app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have the other model file. This is the notebook file, which is a Jupyter notebook file, and it contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells. This is the database file in which we will be storing the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. So I'm copying it. Now open Anaconda prompt. So it is properly initiated. Now give the command cd, give the space and paste the copied path. Now click on enter. Here if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. So copy this local link provided by the Flask framework and paste it into any web browser. I'm copying it and I prefer Google Chrome, so I will paste it in that. Paste the link here. Now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So you can click on get started or you can click on sign up. So let's click on get started. And you need to create an account first. So fill in all these details and sign up. I have already created, so directly sign in. Click on sign in. Give your username and the password. And now click on sign in. We have signed in successfully and redirected to prediction page of this project. So here we have multiple parameters which are used for predicting the obesity risk. So let's understand what are these. The first one we have is a gender. Whether the person is male or female is a gender that can influence metabolism and obesity risk. Then we have age. Age is the age of the person since metabolism and risk factors can change with the age. Then we have height. Height is a person's height used to help calculate body mass index, and other body measurements. Then we have weight. So this is the person's weight, which along with the height helps to assess the obesity levels. Then we have family history with the overweight. It indicates whether the person has family members who are overweight, as genetics can play a role in obesity. So here we have frequent consumption of high calorie food. It is how often the person eats high calorie foods which contain, that is, which contribute to weight gain. Then we have frequency of consumption of vegetables. It is how often the person eats vegetable, which reflects a healthier diet. Then we have number of main meals. It is a typical number of main meals that a person eat per a day. Then we have consumption of food between meals. It is how often the person eats snacks, that is between meals, which can affect the calorie intake. Then consumption of water daily. So this is the amount of water consumed daily, since hydration can influence metabolism and overall health. Then we have calorie consumption monitoring. It is whether the person keeps track of calorie intake, indicating awareness of the diet. Then we have physical activity frequency. It is how often the person exercises, which compares energy, balance, and weight. Then we have consumption of alcohol. It is how often person drinks alcohol, which can contribute to extra calorie intake. Then here we have transportation used. It is primary mode of transportation which affects daily physical activity. So this is all about the parameters. Now let's enter them. For that, let's open the sample file, that is the test cases. So let's open the test cases, open the sample file. Let's start entering them. And let's apply filter to the target that we will be predicting. And we will be not giving this column as the input because this is only that we will be predicting. And let's apply filter. So let's apply filter to insufficient weight. So click on that and click on OK. And let's start entering the values. Where gender is male, age is 17, we need to give the float value, not the decimal value. And height is 1.81. Weight is 58.32. And family history, whether the person has obesity or not, that is yes. And frequency consumption of high calorie food, that is FAVC, is yes. FCVC is 2.25. And we have NCP, that is number of main meals, that is 4 times of main meals he eats. Consumption of food between meals, it is sometimes, so select it on sometime. And CH2O, that is consumption of water daily, is 2, that is 2 liters. And consumption, that is calorie consumption monitoring, is no. And FAF is physical activity, that is 2. And consumption of alcohol, it is no. And here we have transportation, it is automobiles. So select it. Now click on analyze obesity. So this given information, it will be pre-processed at the backend. It will be fed to the train model, and then train model will be giving us the prediction. So just wait for a while. It is being analyzed. So here we have the prediction. Here we have health score of 65%. Is 65% healthy. And BMI category, he is of underweight. And here risk level moderate. So he has moderate risk level. And it is predicting it as insufficient weight. So it is predicting as insufficient weight. So here body mass range is less than 18.5. Health impact is moderate risk. And here we have health assessment where energy levels are 60%, immune system is of 70%, and bone health is of 65%. And these are the potential causes. So insufficient calorie intake, high metabolic rate, underlying health conditions, poor nutrition quality, eating disorders, chronic diseases. So these are the causes. And here we have action plan, what he has to do to gain weight. And here we have being weight can lead to weakened immune system. So here we have osteoporosis, anemia, and fertility issues if he has the same thing again. And here we have nutrition analysis, what he has to take. And here he has activity assessment. And here he has genetic factors. And here you can see your health journey timeline. So week 1, week 2, week 4. So week 1, baseline assessment, initial evaluation, and goal setting has to be done. And here he has week 2 and week 4, what he has to do. And For month 2 and month 3, what will be changed, and plus month 4. Now let's do with new assessment. So let's apply filter to normal weight. Click on OK. And let's fill with these details where gender is female, age is 20, height is 1.5, weight is 44. Yes. Family history is yes. And then F FCVC is, so family history is no actually. Family history with obesity is no. And this one is yes. And FCVC is 2. And number of main meals are 3. Consumption of food between meals is sometimes. CH2O is 1. And then we have calorie consumption, it is no. And then we have physical activity, that is 0. Consumption of alcohol, it is sometimes. And transportation used is automobile. Now click on analyze obesity risk. So here you can see health score is 95%. He is 95% healthy. And here we have body mass category, which is normal. He's normal. And physical, that is risk level, is very low to him. So here his normal weight, and this is the body mass range. It is between 18.5 to 24.9, and his impact is optimal health. That is his good. And here we have health impact assessment, where energy levels are 95%, immune system is 90%, and cardiovascular health is of 88%. And here he has health benefits. How to maintain that health? It is, we can see how to maintain that normal weight, and he can be healthy. And here we have health fact. So this is the health fact that he has to follow. And here we have health insights and recommendations. So here we have nutritional analysis, activity assessment, genetic factor, and here he has health journey timeline. So this is the health journey timeline. Let's try with a new assessment where let's apply filter to obesity type 1. And let's start giving these details. So gender is female, 18 years is his age, height is 1 point, let's copy the value, 1.681719. And then weight is 90.671871 it is. And family history is yes. And consumption of high calorie food is also yes. FCVC is 1.524428. Meals he eats 3 times a day meal. And consumption of food between meals is sometimes. CH2O is 1.38. And then SCC, it is no. That is calorie consumption monitoring is no. And then FAF value, it is 0.13. That is physical activity. And then consumption of alcohol is sometimes. Transportation used is public transportation. Now click on analyze obesity risk. And here you can see we have health score of 45% only, and body mass index category is of obesity level 1, and risk level is high. Here we have obesity type, and here you can see serious health risk, that is he may face with the high diabetes risk, cardiovascular disease, sleep apnea, joint and back pain. And medical approach that need to be done is these things. And here we can see AI health insights and recommendations, assessment, activity assessment, genetic factor, and here we have your health analysis journey timeline. Now let's check with the new assessment. So let's apply filter to obesity type 2. Click on OK. And let's check with this case where gender is male, age is 31, and height is 1.84, weight is 125 kgs. And then family history is yes, that is there are persons in the family who are of overweight, and frequent consumption of calorie food is yes. FCVC is 2.49, that is consumption of vegetables. And meals taken per day is 3. Consumption between meals is sometimes. CH2O is 1.66. And then SCCC, that is calorie consumption monitoring is no. Physical activity is 0.99. And then consumption of alcohol is sometimes. and transportation used is public transport. Click on analyze obesity risk. So here if you observe, health score is very bad, that is 30% only, and here we have body mass index category, that is an obesity 2 stage, and risk level is very high. And here you can see obesity type 2. So here body mass index, that is body mass indicates class 2 obesity, immediate medical intervention is strongly recommended. And here we have critical health risk, where he may have severe diabetes risk, heart attack risk, stroke risk, cancer risk increase, and urgent actions which has to be taken. And here we have AI health insights and recommendations. Here we have activity assessment. Here we have genetic factors. Let's try with a new case. So let's apply filter to obesity type 2. So click on OK. So let's apply filter. We have applied gender is female, age is 25. So let's apply age as 25 and height is 1.6100, weight is 1 or 2 kgs, and family history is yes. There are persons who are raised in the family, and consumption of calorie food is yes. FCBC is 3, number of meals, FCBC is 3 and NCP is 3, and consumption of food between meals is sometimes. CH2 is 1.0205 it is. Calorie consumption it is no. Calorie consumption monitoring is no. FAF is physical activity. And here we have sometimes, and then public transportation. Click on analyze obesity risk. So here you can see health score is only 15%. He is only 15% healthy. And here you can see body mass index category, that is 3. Obesity level 3 he is at. And risk level is critical. It is critical. And here you can see life threatening risk, emergency care which has to be taken, and all other insights also. Now let's do new assessment. So let's check with obesity level 1. Overweight level 1 it is. It is which is more than the obesity. So let's check with this case. And here the gender is female, age is 16 years, height is 1.61, weight is 65, and family history of overweight is yes, consumption of high calorie food is yes, FCVC is 1, and number of meals is 1, consumption between meals is sometimes, and consumption of water daily is 2. And here we have SSC is no, 0, and this is no completely. And here we have public transportation. Now click on analyze obesity risk. And here you can see health score is 75%. And here we have body mass category, that is overweight 1. And here we have risk level, it is moderate. Here we have risk level to be moderate. And here we have overweight level 1. So it is at overweight level. Actually, obesity is the next stage. Overweight is the initial stage. So obesity comes after overweight. And here we have action plan, increase daily activity, AI health insights and recommendations. Here we have activity assessment, genetic factors, and here we have health journey timeline. So overweight is at stage 1. So if they don't take care at this stage, they will get obese in future. So let's do new assessment. Let's apply filter to the last level, that is overweight level 2. And here gender is male, age is 33, height is 1.85, weight is 99, family history weight is yes, frequency consumption is yes, and consumption of vegetables are 2, number of meals are 3, sometimes is the consumption between meals, and consumption of water daily is 3, no, physical activity is 1, consumption of alcohol is sometimes, and transportation is automobile. Now click on analyze obesity risk. So here if you observe, we have health score of 60% and he's at overweight stage 2. After this stage, he will get obese. So if we don't take care at this stage, he will be obese in the next stage after he gains weight. And here we have risk level high. Here we have overweight level 2. So your body mass index significant overweight. It is important to take action to improve your health. And here we have healthcare risks, that is health risks and immediate actions which are to be taken. And here we have nutrition analysis, activity assessment, genetic factors. And this is the health journey timeline if he has to stay healthy. And if we click on download report, we will be able to download the results that we have gained now. Let's check with the graph. So click on view analytics. And here you can see sample outcome graph. So here this on x-axis we have number of obese dead and here on y-axis we have count. So this is the classes that we are finding now, that we are predicting. Close it. And this is the sample outcome in the pie chart. So each color represents one type of class. So this represents, that is the purple represents obesity type, and this color green represents insufficient weight, and this dark green it represents overweight. So like that we have all the other classes represented in pie chart. And here we have correlation matrix. This shows the correlation between independent features. Close it. And here we have cross validation accuracy. So here on x-axis we have number of features selected and on y-axis we have cross validation accuracy. Now click on close. Here we have distribution. So this is the before distribution and this is after distribution. I mean, this distribution is before using smooth technique and this distribution is after using smooth technique. Close it. And here we have classification report. This is the confusion matrix and this is multi-class ROC curve. Close it. And here we have accuracy comparison graph. Here on x-axis we have all the models that we have trained and on y-axis we have accuracy score. And here we have precision score, recall score. Here we have FN score. Here we have ROC AUC score. And here we have explainable SHAP. That is explainable AI SHAP graph, which shows the feature importance. So here, this color represents the high level of importance of feature value, and this color represents lower level of feature importance. Now close this. Click on log out. So in this project, we have built a system, that is smart system, that can help to identify people at risk of obesity early on. By looking at lifestyle habits, diet, and personal details, the system provides meaningful insights that can guide healthier choices. This not only raises awareness about obesity, but also empowers people to take proactive steps towards a healthier life. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.